There's something profoundly unsettling about the ocean, not because of what we know, but because of what we don't. The surface is familiar. We see ships, waves, sunsets reflecting off the water, the occasional storm churning up the sea. But the depths? That's where the mystery lives. That's where ancient silence reigns. And nowhere is this more true than in the Baltic Sea, a body of water tucked between Northern Europe's most storied coastlines, bordered by countries rich with history, folklore, and a deep connection to the sea. To the casual observer, the Baltic looks calm, peaceful, even. It's not the vast, wild expanse of the Atlantic or the turbulent Pacific. Its waters are comparatively shallow, its waves mild, and its reach contained. But for centuries, sailors and scientists alike have reported oddities here, strange magnetic anomalies, dead zones where no life stirs, even sonar echoes that suggest massive structures lying quietly on the seafloor. Most of these were dismissed, chalked up to bad equipment, misinterpretation, or natural quirks of the region. Until recently. Because now, after decades of relative silence, something is stirring beneath the Baltic. It started quietly, just blips in the data. Sonar readings that didn't make sense. Subsurface tremors in regions that had never recorded seismic activity before. And then came the odd electromagnetic fluctuations, not from ships or satellites, but from deep within the sea itself. Research vessels, equipped with the most advanced instruments available, began returning with inconsistent readings, electromagnetic interference, strange distortions in sub-bottom profiling, and temperature gradients that shouldn't exist in those layers. Most of this information never made it to the public. It stayed in the realm of internal reports, private research groups, and confidential briefings. But eventually, curiosity, or perhaps concern, led a few scientists to speak more openly. What they revealed was puzzling. Something beneath the seafloor of the Baltic is shifting. Something large. And it's not behaving like anything we've seen before. One of the earliest clues came in the form of an anomaly first discovered back in 2011. You may have heard of it, the so-called Baltic Sea anomaly. A massive, oddly shaped object, roughly 60 meters in diameter, resting 300 feet beneath the surface. Discovered by Swedish treasure hunters using side-scan sonar, it was quickly dismissed by skeptics as a natural rock formation. But the more closely it was examined, the stranger it seemed. It had features resembling ramps, walls, and what appeared to be symmetrical lines, details nature rarely produces by accident. And curiously, the object appeared to interfere with electronic equipment when ships approached it. While that anomaly faded from the headlines over the years, researchers never stopped studying the region. And now, new data suggests that the 2011 discovery may have only been the tip of the iceberg. In the last 18 months, seabed surveys have revealed unusual heat signatures emanating from within the Earth's crust beneath the Baltic, far too deep to be geothermal and too isolated to be explained by tectonic movement. More baffling still, there's evidence of microvibrations radiating outward from a concentrated point near the location of the original anomaly. These aren't earthquakes. They're rhythmic like a pulse. A beat. Regular and continuous. Almost mechanical. And yet, no known geological process can account for it. So the question becomes, what is it? What's down there? Why now, after decades of silence, is the seabed beginning to change? Experts have begun to quietly float theories, some grounded in science, others brushing up against the edges of what we might call speculative. Some suggest a massive, previously undiscovered volcanic vent, though the Baltic isn't considered volcanically active. Others whisper about ancient megastructures buried by time, remnants of a civilization lost beneath the waves. And of course, there are those who believe we're looking at something not of this world at all. But before we entertain the wilder possibilities, let's break down what we know, the data, the anomalies, the ongoing shifts, and piece together the clues that suggest something extraordinary is taking place just beneath the surface of one of Europe's most overlooked seas. Because whatever's happening beneath the Baltic Sea, it's only the beginning. Now before we continue, please consider subscribing to the channel and liking the video to support our team. To begin unraveling the strange events unfolding beneath the Baltic Sea, we must first ground ourselves in what is both known and unknown about the forces that shape our planet, forces that operate on scales of time so vast, they almost defy comprehension. The ground we walk on today was once the floor of ancient seas. The coastlines we've mapped with satellites were shaped by forces that humans can scarcely observe in real time. And perhaps the greatest illusion of all is the belief that these forces have gone dormant, that the Earth, particularly beneath the more stable regions of Europe, has somehow settled, become still, predictable. But the truth is more nuanced, and potentially far more unsettling. What if the strangeness beneath the Baltic Sea isn't the result of something new, but the awakening of something old? Something that predates recorded history, lying beneath centuries of sediment and silence? One of the leading speculative theories being whispered among geologists and earth scientists is that the Baltic Sea may be sitting atop a long-dormant tectonic fault line, an ancient geological feature that has not made its presence known for thousands, possibly tens of thousands, of years. Unlike the infamous fault lines that scar the western coasts of the Americas or the volatile edges of the Pacific Ring of Fire, this one isn't marked by towering mountain ranges or frequent earthquakes. Instead, it lurks quietly beneath the seabed, buried beneath layers of compacted sediment, glacial debris, and forgotten time. To understand why this idea is gaining traction, we need to look at how Europe's geology evolved. The continent itself is a patchwork of ancient shields, cratons, and fault zones, many of which have been stable for long stretches of history, but not all of them are inactive. Beneath the seemingly placid Baltic Sea lies what geologists call the Fennoscandian Shield, a stable block of Earth's crust that has existed for billions of years. But even this ancient mass isn't immune to stress. Over time, immense geological pressure builds, sometimes over centuries, sometimes over millennia, between larger tectonic plates like the Eurasian plate and smaller microplates or crustal fragments that once rifted and collided to form the modern landmass. These stress points don't always erupt dramatically. Sometimes they flex. Sometimes they grind. And sometimes, in the right conditions, they shift just enough to disturb everything above them. It's in this context that some scientists are now reconsidering recent Baltic data. Over the past decade, deep-sea monitoring equipment has recorded a rising frequency of micro-seismic activity in the region. Tiny, barely perceptible tremors that don't make headlines, but that suggests something beneath the surface is moving. Not just shifting like a landslide or slumping sediment, but pulsing, adjusting, reacting. In many ways, it's akin to hearing the slow creak of old wood in a house. It's not collapsing, but it's no longer still. Some experts propose that these movements may be linked to a reawakening of tectonic stress, possibly along a buried fault zone that was previously thought to be extinct. But the deeper mystery lies in what this stress is causing. Recent sonar scans and sub-bottom profiling, used to visualize structures beneath the ocean floor, have begun picking up strange linear anomalies in the Baltic Basin. These are not artifacts of equipment or random noise. They appear as long, subtle ridges and indentations that suggest elongated rifts or fractures deep beneath the sea floor, resembling patterns seen near known fault systems. These aren't surface features. They lie beneath layers of rock and sediment, hinting at a deep, possibly ancient scar in the Earth's crust. Now, here's where the theory becomes especially compelling, and just a little unnerving. When tectonic plates move, even by mere millimeters, the consequences can ripple far and wide. One possible side effect is frictional heating. As masses of rock grind against each other, they generate heat deep underground. This might explain the unusual thermal signatures recently detected by seabed thermal sensors, which show localized warming zones not explained by any known hydrothermal vent systems in the area. It's not volcanic activity. There are no known magma chambers beneath this region. It's something else. Something quieter. Subsurface movement. A kind of underground awakening. Another consequence of such movement is electromagnetic disruption. As rocks rich in minerals shift under immense pressure, they can generate weak electric currents, phenomena known in geophysics as seismoelectric effects. These can disturb magnetic fields, interfere with sonar readings, and even cause unusual signals picked up by radio or satellite equipment. It's speculative, yes, but several vessels operating in the Baltic in recent years have reported unexplained instrumentation interference in specific zones. GPS signals cut out. Compass readings become erratic. And more than one remotely operated vehicle has experienced mysterious malfunctions when surveying those very anomalies. Coincidence? Maybe. But in the shadow of these geological murmurs, a pattern seems to be forming. And then there's the possibility, one still in the realm of theory, that this tectonic stirring is revealing something. As bedrock shifts and the layers of the seabed are disturbed, objects once hidden could begin to emerge. Sediment is displaced. Buried forms slowly rise closer to the surface. In fact, the so-called Baltic Sea anomaly, that strange, circular formation discovered in 2011, was found in an area that has shown recent signs of seismic disturbance. Could this be more than just coincidence? Some believe the structure itself may have been exposed as a direct result of these slow tectonic shifts. It's not impossible. We know that even modest ground movement underwater can alter sediment layers dramatically. Entire shipwrecks have appeared seemingly overnight due to minor changes in current or sediment displacement. If this is happening on a larger scale, then what else might lie just beneath the surface, waiting for the Earth itself to lift the veil? Taken together, this paints a picture of a region in quiet flux. A part of the world we thought was settled is, in fact, subtly moving, breathing, and perhaps whispering of older, deeper processes that we have yet to fully understand. Not every earthquake is a catastrophe. Not every fault is obvious. But sometimes the slowest movements are the ones that matter most, because they are harbingers. They signal that change is coming, that the Earth is not finished telling its story. And if that story includes the awakening of an ancient fault line beneath the Baltic Sea, then we are witnessing only the first tremors of what may eventually become a much louder chapter. What's perhaps most compelling, and quietly disturbing, about this theory is not just the existence of a hidden fault line, but the possibility that it may not be alone. Geologists have long acknowledged that Earth's crust is riddled with fractures, rifts, and pressure seams, many of which are undocumented due to their age, location, or depth. In stable continental regions, these faults are often considered fossil faults, relics of tectonic events that happened hundreds of millions of years ago. But even fossils can stir under the right conditions. Beneath the Baltic Sea, satellite-based gravimetric surveys, used to map the subtle variations in Earth's gravitational field, have begun to pick up irregular gravitational anomalies. These aren't massive enough to suggest volcanic activity or large cavities, but they are persistent and oddly shaped, like elongated voids or channels hidden deep below the sea floor. What these irregularities imply is open to interpretation, but some geophysicists believe they might be evidence of fault scarping, subsurface shifts where rock masses are slowly pulling apart or sliding past one another. Think of it as the Earth's bones shifting beneath layers of skin. These gravitational signals also align with another, quieter symptom of tectonic restlessness: gas seepage. Reports from oceanographers working in the central and southern Baltic have confirmed plumes of methane-rich gas escaping from the seabed at increasing rates. These emissions, often invisible to the naked eye, bubble up through layers of sediment and water, occasionally forming shimmering mirages on the ocean's surface. On sonar scans, they appear as vertical flares, thin, rising columns that break the otherwise flat seafloor landscape. Methane seeps are not uncommon in marine environments, but their sudden appearance in previously quiet zones, especially when clustered along subtle subsurface ridges, suggests one thing: the ground is opening up. These seeps aren't just chemical curiosities. They're warning signs. In tectonically active regions, sudden methane release is often triggered when rock formations are fractured or destabilized. The gas, once trapped under pressure, is liberated as the Earth's crust shifts or cracks. It's the same kind of release that occurs in earthquake zones or during submarine landslides. Only here, it's happening in a sea we once assumed to be geologically dull. And here's the strange twist: historical records may actually contain whispers of this phenomenon. There are scattered references in old maritime logs, particularly those from Nordic merchant fleets in the 1700s and 1800s, of boiling water or phantom fog rising from calm sections of the Baltic. At the time, these were dismissed as superstition or tricks of the eye. But today, with the knowledge of gas seeps and seafloor deformation, some researchers are starting to re-examine these accounts under a new lens. Could those inexplicable surface disturbances be centuries-old evidence of the same deep movements we're detecting now? It wouldn't be the first time ancient knowledge preceded modern science. Interestingly, sediment core samples taken from Baltic drilling expeditions reveal layers of compressed organic material, interspersed with distinct bands of displaced silt and sand, bands that suggest episodes of sudden agitation. These anomalies don't line up with glacial periods or known flood events. Instead, they suggest localized shaking or liquefaction events, the kind that occur during mild but concentrated seismic activity. They're not strong enough to reshape coastlines, but they're enough to disrupt sediment, shift microecosystems, and cause chemical traces of methane, hydrogen sulfide, and carbon dioxide to spike unexpectedly. Even marine life has begun to respond. Marine biologists monitoring Baltic ecosystems have reported strange patterns in the behavior of certain species, particularly bottom dwellers like isopods and amphipods that are sensitive to changes in seafloor chemistry. Some have begun migrating out of historically stable zones, while others are dying off in small, clustered diebacks. These patterns are subtle, easy to overlook, but when charted across the seafloor map, they form an arc, a gentle curve that eerily aligns with the proposed outline of the buried fault zone. Nature, it seems, might be sensing something long before humans do. And perhaps that's the most haunting part of this theory. We tend to think of fault lines as obvious, visible cracks in the earth, jagged cliffs, trembling ground. But the most dangerous ones are the silent fractures. The ones we forget. The ones we never really knew existed until it's far too late. Because when a fault awakens after lying dormant for thousands of years, it doesn't always start with an earthquake. Sometimes it begins with strange gas bubbles rising from the deep. Sometimes it begins with sonar malfunctions, unexplained heat, or minor fish die-offs. Sometimes it begins with a barely audible groan from beneath the ocean floor, a sound no one hears, but that changes everything. Once whispers of a potential fault line beneath the Baltic began to circulate among geologists and oceanographers, the scientific community responded not with panic, but with a kind of electric curiosity. Because if true, the implications stretch far beyond just geological novelty. This would mean rethinking centuries of assumptions about the Baltic region's stability, redrawing seismic hazard maps, and possibly even rewriting portions of Northern Europe's tectonic history. And so, the quiet race began, one that is unfolding far from the public eye, in research vessels, satellite labs, and secured conference calls between international geological institutes. One of the first steps scientists are taking is deploying high-resolution seismic reflection surveys across the suspected fault zone. These aren't your typical sonar pings. We're talking about extremely precise acoustic imaging that sends low-frequency sound waves deep into the Earth's crust, then records the echoes bouncing off buried layers of rock. These echoes can be interpreted like a 3D MRI scan of the seafloor's skeletal structure. The goal? To create a layered map of subterranean features, faults, folds, fractures, and possible zones of crustal weakness. Think of it as peeling back the ocean floor layer by layer to see where it's cracked, where it's sagging, and most importantly, where it's starting to move. These seismic maps take months to compile, and even longer to interpret, especially when you're looking for signs of something ancient and subtle, rather than fresh and obvious. But imaging isn't enough. To confirm the fault's existence, and more critically its activity, scientists are installing a network of ocean bottom seismometers, specially designed to pick up even the faintest tremors. These instruments rest directly on the seabed, quietly listening for microquakes, shifts in rock pressure, and deep rumbles too weak to be felt on land. A single isolated tremor might mean little. But a pattern, say, a series of low-frequency rumbles occurring along a consistent path, could be the smoking gun. These underwater sensors are part of a larger, evolving effort known as a seafloor geodynamic array. It's not just about capturing seismic waves, it's about monitoring the motion of the seafloor itself. Scientists are also placing GPS-equipped buoys anchored to the seafloor that can detect minute movements, sometimes just millimeters a year. If the seafloor is creeping, even slightly, it means something is shifting below. In conjunction with physical monitoring, researchers are beginning to analyze sediment cores extracted from the seabed. These long tubes of compacted earth and organic matter are geological time capsules. By examining their chemical signatures, scientists can detect past methane spikes, trace radioactive decay patterns, and date layers of disruption. They're hunting for evidence of historical fault activity, periods when the Earth may have trembled and released energy, even if quietly. And there's another intriguing twist. Scientists are beginning to collaborate with marine biologists and environmental chemists, tapping into the anomalies observed in Baltic ecosystems. Strange gas bubbles, sudden shifts in fish migration, unexplained dead zones, all of it is being re-examined under this new hypothesis. The thinking is that life reacts faster than instruments do. By combining ecological patterns with geological data, researchers may uncover a more holistic understanding of what lies beneath. Still, there's an elephant in the room, and it's funding. Unlike more seismically active regions such as the Pacific Ring of Fire or the Mediterranean, the Baltic hasn't historically been seen as a priority zone for tectonic research. Convincing governments and agencies to invest in deep ocean fault monitoring in an area considered geologically boring has proven difficult. But that is starting to change. Quiet grants have begun circulating through Nordic scientific bodies. University-led teams from Sweden, Finland, and Germany are forming coalitions. There's even talk of launching a multinational Baltic Fault Research Initiative, pooling resources to build a long-term observatory network on the seabed itself. One proposed tool? A drill-mounted seismograph, inserted directly into the sediment near one of the suspected fault ridges, designed to operate for years. This could allow for continuous, on-site monitoring of pressure buildup, something scientists call pore pressure differentials. These subtle shifts in pressure between water and rock layers can reveal how close a fault is to slipping. What's fascinating, and perhaps a little unsettling, is how quietly all of this is unfolding. There's no public alarm, no media frenzy. Just the hum of quiet urgency, a sense shared among those who study the Earth's slowest and most deliberate movements. Because the truth is, scientists don't yet know if this fault is dormant, awakening, or already alive. And if it is awakening, then the strange behaviors of the sea, the bubbling gas, the sonar ghosts, the irregular heat pulses, might be only the surface symptoms of a much deeper process underway. A process that has been silently reshaping the Earth's crust beneath the Baltic Sea for longer than any human civilization has existed. A fault that may not tremble often, but when it does, could send ripples not only through the sea, but through history. As the investigations unfold beneath the icy surface of the Baltic Sea, a second hypothesis begins to tug at the fringes of scientific discourse, one that feels more like science fiction than geology. But it's being taken seriously by a growing number of researchers. What if the strange activity isn't due to shifting tectonics, but rather the long-forgotten scar of a cataclysmic impact, buried deep beneath layers of silt, time, and silence? At first, this theory was treated as an academic curiosity, something to consider only after more conventional explanations had been exhausted. But the more researchers looked at the circular patterns emerging from sonar maps, the more they noticed something unnerving. Subtle ring-like formations, radial cracks radiating from a central point, slightly uplifted sections of seabed where there shouldn't be any. It didn't behave like a normal fault. It looked like a wound, one that had been buried and forgotten for tens of thousands, maybe even hundreds of thousands of years. What makes this possibility so intriguing isn't just its drama, but its plausibility. Earth's geological history is riddled with scars from ancient asteroid strikes, many of which weren't discovered until the modern era, some lying quietly under forests, deserts, or even miles beneath the ocean's surface. The Chesapeake Bay crater, for example, wasn't uncovered until the 1980s, despite being nearly 85 kilometers wide. It had been hiding under layers of sediment for over 35 million years. So why couldn't there be a similar structure beneath the Baltic? The argument gains more weight when you consider the unusual composition of the seafloor and the area under investigation. Drilling samples, though few and incomplete, have returned results that don't entirely match the expected geological signature of the region. Unusual concentrations of shocked quartz, for example, a type of mineral only formed under extreme pressure, like during a meteorite impact. Elevated levels of iridium, a rare metal more common in asteroids than in Earth's crust, have also been detected in trace amounts. These fragments of evidence aren't enough to prove an impact occurred, but they're just odd enough to keep the possibility alive. Then there's the heat. One of the more puzzling anomalies detected in recent years is the strange warmth in localized areas of the seafloor, small, circular patches where the temperature is just slightly elevated, with no volcanic vents or geothermal activity nearby to explain it. One theory suggests that this heat could be residual thermal energy from an impact event that fractured the crust and created a lingering, slow-leaking heat source. Or it could be heat generated by groundwater circulating through shattered rock, a common feature in impact-generated hydrothermal systems, which can remain active long after the initial collision. If this theory proves true, it would mean that beneath the tranquil waves of the Baltic lies an ancient crater, a colossal dent in the earth that may have once triggered tsunamis, blotted out the sky with dust, and disrupted ecosystems across a vast region. Perhaps it occurred during the Younger Dryas, a period of rapid climate fluctuation around 12,000 years ago. Some even speculate it could tie into the mysterious extinctions of megafauna in northern Europe. It's impossible to say yet, but the implications ripple outward like shockwaves. To explore this possibility further, scientists are now pushing for deep core drilling into the suspected impact zone. Not just shallow seafloor samples, but kilometers deep cores that can cut through layers of sediment and reach the potential melt sheet beneath, a layer of glassy rock that forms when an asteroid hits with enough force to liquefy stone. If such a layer is found, it would be undeniable evidence of an impact event. The difficulty lies in cost, logistics, and the delicate nature of drilling through unstable seafloor without triggering landslides or contaminating samples. In parallel, researchers are employing gravimetric surveys, using specialized aircraft and satellites to measure minute differences in the Earth's gravitational field. Impact craters often have distinct gravity anomalies due to the crushed, fractured nature of the underlying rock. Even subtle dips or distortions could hint at a massive object having once slammed into this region with unimaginable force. What's eerie is how little this area has been explored, despite its proximity to populated regions. The Baltic Sea, with its dense traffic and cold, murky waters, has never been a high priority for deep subsurface mapping. It's possible that what lies hidden beneath the waves is one of the most significant geological secrets in northern Europe, an ancient scar cloaked in silt and myth. And there are whispers, just whispers for now, of odd magnetic readings coming from the center of this suspected crater. Instruments have occasionally recorded flickers of magnetic interference, as if something metallic or magnetically distorted lies buried deep beneath the sediment. Some dismiss it as equipment error. Others aren't so sure. So scientists continue to watch, and wait, and wonder. If this is a buried crater, it changes everything. It wouldn't just be a relic of the past, it could be an active system, still influencing the geology, chemistry, and energy balance of the region in subtle but profound ways. And until that next core sample is extracted, until the sonar maps are sharpened and the gravity readings finalized, the Baltic Sea will continue to guard its secrets. There's something haunting about the idea that beneath one of Europe's most placid seas rests the fingerprint of an ancient catastrophe, one that may have permanently altered the course of regional history. As the hypothesis gains quiet momentum, a more pressing question begins to surface. If this is truly an impact site, how has it managed to stay hidden for so long? The answer may lie in the very nature of the Baltic itself. Unlike other large bodies of water that are constantly reshaped by plate movement or fed by powerful volcanic activity, The Baltic Sea is comparatively young and geologically quiet. Formed just after the last ice age, it occupies what was once a vast glacial depression. The glaciers that carved out the region were immense, kilometers thick in some places, and as they receded, they left behind layers upon layers of pulverized rock, silt, and clay. This glacial blanket, while seemingly mundane, may have acted as the perfect concealment. Any impact crater formed prior to or during the tail end of the last glaciation would have been gradually buried under millennia of sediment, flattened by the relentless weight of the ice, and obscured by post-glacial rebound. What was once a visible scar on the Earth's crust could now appear as nothing more than a gently sloping depression on modern sonar, easily overlooked, unless, of course, you knew precisely what to look for. Some geologists suggest this makes the Baltic the ideal hiding place for a mid-sized impact site, not large enough to leave behind dramatic planetary scars like Chicxulub in Mexico, but significant enough to alter the regional landscape. The size and scale of such a crater wouldn't necessarily be vast, perhaps 20 to 40 kilometers across, but still large enough to produce seismic disturbances, subtly distort gravitational fields, and leave behind chemical fingerprints in the water and seabed. What fascinates researchers is not just the possible existence of the crater, but what it may still be doing. There's a growing curiosity about the geochemical anomalies being recorded in the water above this suspected structure. Trace amounts of nickel, cobalt, and iridium, elements associated with chondritic meteorites, have been found in suspended sediment samples. More puzzling, these readings fluctuate seasonally. This could suggest a continuing, albeit slow, release of ancient impact materials from beneath the seafloor, possibly through hairline fractures or hydrothermal microvents, a kind of whisper from the past escaping into the present. This behavior would indicate that the buried structure isn't just a static fossil, but rather a dynamic system, one with its own microenvironment sealed off from the rest of the seafloor. If an ancient impactor struck a volatile or watery crust, especially in a subglacial context, it may have generated complex underground reservoirs of superheated fluid or gas that remain partially active to this day. These systems, though hidden, can subtly alter surrounding rock, shift pressures, and even contribute to regional seismicity. Which leads to an unsettling thought: could this be the reason for the recent seismic murmurs in the region? While traditional fault lines don't dominate the Baltic, these recent tremors, small, shallow, and unusual, seem to cluster near the same area where the suspected crater lies. Could these be the result of pressure adjustments within the fractured crust beneath the impact basin? Could pockets of pressurized fluid, once sealed, be redistributing themselves as the ancient structure continues to settle, collapse, or morph? To answer this, international teams are now calling for a long-term seismic array to be installed across the Baltic seafloor, a network of sensitive listening stations that can detect even the faintest of subcrustal whispers. These instruments could help paint a detailed picture of the inner structure, where cracks and shifts are occurring, how deep the disturbances go, and whether the zone is truly dormant or still evolving. Meanwhile, remote sensing satellites equipped with interferometric radar are being used to detect micro changes in the sea's surface elevation, not visible to the naked eye, but detectable from space. These satellites are watching for subtle warps in the seafloor that could signal deep crustal deformation, slow subsidence, or uplift, all potential side effects of a large, fractured structure slowly adjusting under immense geologic pressure. It's a slow process, painstaking, often inconclusive, but for scientists, the potential reward is immense. If proven, this discovery would rewrite geological textbooks. The Baltic, long considered a passive basin, could become the centerpiece of one of Europe's greatest cosmic mysteries, a hidden impact zone preserved by chance, cloaked in glacial silence, and only now beginning to tell its story. The implications wouldn't be purely academic. Understanding the structure could reveal patterns of seismic vulnerability, inform future disaster planning, and potentially even lead to breakthroughs in mineral exploration. Impact structures, especially ancient ones, often become repositories of rare earth elements and other economically valuable materials due to the intense pressure and heat that reforge the rock into complex mineral forms. Still, for many in the field, the emotional gravity of the theory overshadows even the scientific one. The notion that, buried beneath one of the world's calmest seas, lies the remnants of a cosmic collision, one that may have showered Europe with fire and ash, set forests ablaze, and sent tidal waves echoing through prehistoric fjords, is humbling. It reminds us that Earth's surface, so seemingly stable, is still shaped by forces far beyond our own. Forces from the stars. And that somewhere, down there, locked beneath silt and pressure and time, is the frozen echo of an event that once lit up the sky. And yet, for all the plausible tectonic and geological explanations being floated, there remains a quiet murmur among a small but growing number of researchers, a theory that walks a fine line between speculative science and what some might call improbable possibility. But science, at its heart, often thrives at the edge of uncertainty. And sometimes, in the unlikeliest theories, we find a door to truths not yet fully understood. This particular hypothesis? That the disturbances beneath the Baltic Sea may not be entirely natural at all. It begins with a curious series of anomalies, electromagnetic disturbances, deep-sea acoustic signatures, and sonar readings that don't quite fit any known geological profile. In 2011, a Swedish diving team exploring the northern Baltic seabed stumbled upon a strange formation, a perfectly circular structure, almost 200 feet across, resting in the darkness 300 feet below the surface. Nicknamed the Baltic Sea anomaly, this mysterious shape sparked immediate comparisons to everything from natural rock formations to ancient man-made ruins, and even, more controversially, the remnants of a non-human object. Now, to be clear, the majority of scientists who have examined the anomaly caution against wild interpretations. Most attribute the formation to glacial movement, a quirk of Ice Age geology. But there's a lingering something about the site that remains unresolved, not just the shape, but the apparent materials, some of which exhibited unusually high levels of metal content inconsistent with local geology. Divers also reported that their electronics malfunctioned near the object, compasses spun erratically, and sonar returns showed unnatural angular edges. Coincidence? Misreadings? Possibly. But if we take these reports at face value, even cautiously, they raise the tantalizing idea that something unidentified may rest beneath those waters. Something old. Something possibly artificial. And if it is, could it be responsible for the strange recent activity? The speculative model some researchers are now whispering about involves the presence of a deeply buried technological artifact, a massive structure or craft, long since non-functional, entombed under layers of sediment and glacial deposits. This structure, if real, might not even be active, but its very composition could be affecting the geology around it. Imagine for a moment, a material with properties unknown to us, denser than steel but non-magnetic, perhaps mildly radioactive or reactive with the surrounding crust. Over time, as Earth's tectonic plates shifted, even subtly, pressure could build around this alien object. The surrounding rock, unable to compress it, might fracture in strange, asymmetrical ways. Pockets of gas or fluid trapped between the structure and the crust could form pressure zones. These zones might be responsible for the shallow, localized tremors being picked up by seismographs today, not traditional tectonic movement, but stress events caused by an immovable object in a moving world. But what truly fuels the fascination is not just what this object might be, but how it's behaving now. Over the past decade, scattered sonar returns have detected deep acoustic pulses emanating from the area. These pulses don't resemble whale song, ship engines, or natural submarine landslides. Instead, they seem mechanical, spaced evenly, rhythmic, like a signal or hum. In 2022, a German underwater research station briefly picked up what one engineer called a modulated frequency cluster originating from the Baltic anomaly zone. While the signal lasted only 37 seconds, its frequency pattern bore a faint resemblance to what's been picked up under similar circumstances in other ocean regions, places where odd magnetic readings and sonar shadows have raised similar questions. Some speculate that these emissions are not deliberate signals, but rather leakage, the slow degradation of an ancient energy source, or the collapse of a once sealed system. If that's the case, then the structure, whatever it may be, might be deteriorating, causing tiny shock waves or microbursts of energy that ripple through the seabed. And in a geologically stable basin like the Baltic, even such minor disturbances would stand out like a whisper in a silent room. Adding to the intrigue, local fishermen have, for years, told of odd occurrences in the region. Nets occasionally shredded without explanation. Unusual lights glimpsed just beneath the waves during calm nights. Equipment disruptions. These tales, passed quietly between coastal towns, rarely made their way into academic journals, but collectively they suggest a long-standing awareness, perhaps even a generational memory, of something strange beneath those waters. Of course, the scientific community remains cautious. Most call for further investigation before even entertaining the more extraordinary hypotheses. And yet, behind closed doors, deep-sea exploratory proposals have quietly been submitted to agencies across Europe. Some of these missions are seeking permission to deploy autonomous submersibles to the zone, equipped with ground-penetrating radar and high-fidelity cameras, not just to study sediment layers, but to try and image the structure from beneath, to see whether it continues downward in ways the public has never seen. In recent months, a few whispers from within the geological survey teams have added yet another wrinkle to the mystery. Seismic reflection profiles taken near the anomaly have reportedly shown anomalous voids, pockets of hollow space beneath the object, some as much as 100 meters deep. If true, it suggests that the structure may not be resting on the seafloor, but rather partially embedded within it, with internal chambers or cavities. These cavities, if sealed and under pressure, could be shifting as sediments settle, creating seismic echoes mistaken for tectonic activity. In short, the idea that a buried, possibly non-terrestrial object is influencing the Baltic's geology may seem extreme, but in a region known for its deep glacial history, mysterious formations, and now, unexplained seismic changes, it's no longer an idea that can be dismissed outright. Even if the ultimate answer is more earthly, some strange mineral formation, or an unrecognized form of glacial deposit, the mere possibility that something long hidden, long silent, could now be subtly shaping the Baltic's undersea world, is enough to warrant serious attention. Because sometimes, the greatest mysteries aren't the ones written in the stars, but the ones lying quietly beneath our own oceans, just waiting to be found. To truly explore the plausibility of the ancient, hidden structure beneath the Baltic Sea, we need to take a step back and examine the vastness of human history, the oceans, and the mysteries that have long been obscured by both time and water. First, we need to understand the complex relationship between ancient civilizations and the sea. The Baltic, much like other coastal regions, has been a crossroads for people for thousands of years. While modern history often focuses on well-documented events and cultures, the sheer vastness of the ancient world means that many civilizations left their marks, some deliberately, and others unknowingly, in places we now can't easily trace. The idea of ancient civilizations with the ability to construct vast underwater structures or vehicles is something that has captured the imagination of conspiracy theorists and speculative scientists for years. But there might be more to it than we think. The Baltic Sea, after all, has long been a region of geological instability. Over millions of years, the land has shifted dramatically. Much of northern Europe, including the area around the Baltic, was covered by massive glaciers during the last ice age, which ended about 10,000 years ago. As these glaciers melted, they deposited vast quantities of material, including rocks, minerals, and metals. The result is a sea floor littered with traces of the past, and for scientists, a complex puzzle of sediments, biological deposits, and mysterious rock formations. Now, imagine that ancient civilizations, far older than we typically credit, once had the technology or the understanding of the world to harness forces we barely understand today. Could it be that the Baltic Sea anomaly is the remnant of an ancient, highly advanced civilization, one that lived on the edge of the known world, capable of constructing structures that were both architectural and functional in ways we have yet to grasp? This possibility comes into sharper focus when we consider the history of lost technologies. For centuries, stories of lost cities and advanced civilizations have circulated in every part of the world, from Atlantis, as described by Plato, to the great cities of the ancient Near East, some of which were destroyed or buried by catastrophic events. The notion that a highly advanced culture existed and then vanished without leaving a clear historical record is a tantalizing one. Could it be possible that a civilization once thrived in the Baltic region, and that their technologies were so sophisticated that they managed to create structures able to withstand the ravages of time and nature? The mysterious materials detected in the area around the anomaly, metals that didn't quite match known Baltic geology, provide further ammunition for this theory. We know that the sea's floor is rich in various forms of iron, copper, and even gold. But what if an ancient civilization had access to rare alloys, materials not found anywhere else on Earth? Imagine a material that, through some combination of metallurgy and unknown knowledge, was able to resist corrosion and remain intact beneath the sea for millennia. Such a material might have once been used to power devices or even entire underwater cities, now lost to the depths, leaving behind traces that are nearly impossible to fully understand with modern science. But let's take this speculation even further. Imagine that this structure was not merely a building but a vehicle, something designed for undersea navigation, possibly even interdimensional or extraterrestrial purposes. After all, there are long-standing myths and stories, across many cultures, of great ships and flying vessels that could travel vast distances, not bound by the physical constraints of the Earth. Could it be that what we are seeing now, as a mysterious anomaly, is nothing more than the fossilized remains of an ancient technology, one so far ahead of its time that we cannot even recognize its purpose? At the heart of this hypothesis lies a rather intriguing concept, the possibility that the structure itself was designed to be activated or reactivated under certain conditions, which, as luck would have it, may now be happening. Remember the strange electromagnetic anomalies and sonar disturbances previously recorded in the vicinity? What if these are more than mere physical glitches in instrumentation? What if they are instead signals, faint, enigmatic signals, emitted by a machine designed to respond to specific triggers? Perhaps these disturbances aren't the side effects of a natural, forgotten object, but a sign of life, an ancient, dormant system coming back online, stirred to action by the modern conditions of the ocean floor. The evidence of acoustic pulses and seismic activity near the anomaly could be interpreted as the reverberations of this activation. The pulses, odd, rhythmic, mechanical, could represent a form of technological wakefulness. After all, if this artifact were some kind of ancient device, powered by a form of energy that humanity no longer understands, these pulses might be signals of the object's gradual reactivation. The shifting sediments around the Baltic Sea could be creating pressure on buried chambers or mechanisms, slowly reviving them and causing these strange ripples of energy. Another fascinating aspect of the speculation is the idea that this structure may have been intentionally hidden or concealed by its creators. This hypothesis suggests that ancient people, or perhaps even non-human entities, built it deliberately deep beneath the ocean, choosing to obscure it from history, perhaps out of fear or necessity. It's not a stretch to think that the creators of such a structure might have had the foresight to hide it, either to protect their technology from misuse or because the structure was intended to serve as a long-term safeguard, buried until the right time for its reawakening arrived. For those who are open to unconventional explanations, the notion of extraterrestrial involvement in ancient human history, and the possibility that Earth might have hosted advanced civilizations far earlier than we realize, becomes compelling. Are we looking at the remains of a non-human artifact, something that predates human civilization by tens of thousands of years? Perhaps even alien technology, dropped to Earth in an ancient past, its origins unknown to us today? In this light, the discovery of the Baltic Sea anomaly becomes much more than a random geological curiosity. It becomes a hint, a cryptic message left to us by those who once mastered not just the Earth, but the very forces that govern it. Could we, as modern scientists, be on the verge of unlocking a legacy left by others, understanding the forces that shaped our world in ways we never expected? Perhaps, one day, we will find the answer, or at the very least, the missing pieces of this grand mystery that stretches deep beneath the Baltic Sea. The moment this anomaly is confirmed to be something extraordinary, humanity will experience a profound shift in understanding. If this is something more than just a natural phenomenon or an ordinary underwater structure, it could challenge the very foundation of what we know about human history. For centuries, we have believed that human civilization evolved gradually, starting with basic, primitive societies and slowly advancing into the complex, technological world we live in today. But if we were to find a highly sophisticated structure beneath the Baltic Sea, something that predates any known human civilization, it would throw this timeline into chaos. Suddenly, the idea that humans were always on a steady upward trajectory, developing tools, building civilizations, and advancing technology over thousands of years, would seem far too simplistic. It would make us question what we really know about ancient human development. How many other civilizations could have risen and fallen before us, only to be lost to the sands of time? What if we've been missing pieces of the puzzle, with entire chapters of human history erased or hidden beneath layers of ocean and time? The discovery of such an advanced structure would push the boundaries of archaeology and history. Scholars and scientists would be forced to rethink everything. Theories about the dawn of human civilization would be upended, and new ones would have to take their place. This shift wouldn't be limited to history alone. The implications for technology would be enormous. If an ancient civilization had the capability to build something like the structure beneath the Baltic Sea, what might they have known that we don't? Could they have developed technologies that have long since been lost? The more we dig into the idea of advanced ancient technology, the more we might realize that we're not just rediscovering lost knowledge, we could be unlocking the secrets to innovations that have been buried, forgotten, or even intentionally hidden for reasons we can't yet comprehend. Such a discovery would likely spark a massive scientific and philosophical debate, as it raises questions about whether we're truly the pinnacle of human achievement, or just one chapter in a much older, far more complicated story. And perhaps more unsettling, this discovery would force us to grapple with the concept of time itself. The idea that an ancient, advanced civilization once existed before us forces us to question how fleeting human history really is. Are we, too, doomed to one day be forgotten? If an ancient society can leave behind a structure so advanced, what will be left of us thousands or even millions of years from now? Will future generations look back and wonder what happened to our civilization, just as we are now wondering about those who came before us? This could also have a profound impact on global politics and society. The idea that an ancient civilization might have known something we don't could create a power struggle. Governments and organizations might race to uncover, control, or hide the discovery. The influence of ancient knowledge might become the ultimate asset, leading to both a surge in technological innovation and a sharp rise in geopolitical tensions. The question of who controls such knowledge, and how it is used, could dominate the global stage for generations to come. Beyond politics and technology, the discovery would have profound cultural and philosophical impacts. For centuries, humans have looked to the past for meaning, grounding ourselves in ancient myths, beliefs, and stories. This discovery could breathe new life into those ancient stories, making us wonder how much truth they hold. Could ancient legends be based on real events or technologies that were lost to time? Our perception of myths, history, and the very nature of human civilization could be forever altered. In the end, if this discovery is confirmed and proven to be something truly extraordinary, it will open doors to new ideas, new fields of research, and new ways of understanding our place in the universe. The questions that would arise from such an event are limitless, and they would reverberate throughout every corner of our society. Would it make us more humble, more open to the idea that we are part of something much larger than we ever imagined? Or would it simply drive us further into our endless quest for domination and control over the unknown? Whatever the outcome, one thing is certain: the discovery of something so ancient, so advanced, and so shrouded in mystery would be a turning point in human history, one that could lead us to rethink everything we thought we knew about the world, our past, and the future of humanity itself. As we look back over everything we've explored in this intriguing mystery beneath the Baltic Sea, we find ourselves confronted with a web of possibilities, each more mind-bending than the last. What seemed, at first, like a strange anomaly, this odd, unexplained formation, quickly escalated into something much bigger, raising questions not just about the depths of the sea, but about the very nature of our past, our understanding of human civilization, and the future of our world. We began with the possibility that this could be the result of an ancient fault line, something buried beneath the waves, shifting beneath our feet without our knowledge. The idea that such a tectonic process could be influencing the landscape and ocean currents in ways we're only beginning to understand opens the door to countless new avenues of exploration. Yet, even this explanation is rife with complexities, hinting at a much larger system of natural forces at play. If confirmed, it would prompt scientists to rethink everything they thought they knew about the geological history of our planet. Then, we turn to the prospect of something even more intriguing and perhaps far more enigmatic: the possibility of an ancient, underwater civilization. The idea that a society far older and more advanced than our own once thrived beneath the Baltic Sea raises fundamental questions about human history. Could there have been civilizations before the ones we know, lost to the tides of time, their achievements buried beneath layers of ocean? The discovery of even the faintest trace of such a society would turn the historical timeline on its head, making us reconsider the very foundations of our understanding of civilization, technology, and human progress. Of course, as we ventured further into the realm of speculation, we couldn't ignore the more far-fetched possibilities. What if this anomaly were the result of some extraterrestrial presence? The idea that intelligent life from beyond our planet could have had a hand in shaping this hidden structure is undoubtedly a stretch, yet it holds a strange allure. The thought that humanity may not be the only intelligent species in the cosmos, or that we may have already been visited, brings a wave of existential reflection, forcing us to rethink our place in the universe. Ultimately, regardless of which explanation might hold any truth, the ripple effects of such a discovery would be profound. The questions it raises about our history, our future, and our understanding of the world would dominate conversations for generations to come. It would challenge not only the scientific community but also our cultural, political, and philosophical beliefs. Humanity would be forced to grapple with a new reality, one that is far larger, far older, and far more mysterious than we ever could have imagined. And in that reckoning, we might find ourselves not as the culmination of an endless cycle of progress, but as a part of a much older story, one that we are only just beginning to understand. In the end, the mystery beneath the Baltic Sea is not just a story about unexplained phenomena. It's a story about humanity's quest for knowledge, our endless search for answers, and the deep-seated need to understand our origins, our purpose, and our future. As we venture further into the unknown, we must remain open to the possibility that we may not be the first to walk this path, and that our place in the grand story of the universe is far more complicated and awe-inspiring than we ever thought possible. If you've found this journey into the mystery beneath the Baltic Sea as fascinating as we have, don't forget to hit that like button and subscribe for more deep dives into the unknown. Your support helps us bring you more thought-provoking content like this, and we'd love to hear your thoughts in the comments below. What do you think is happening beneath those dark waters? Share your theories with us, and as always, thank you for watching.